When you look at the correlations, remember our target variable is the death event. Let's look at the kind of figures that we have in our matrix here. You can see our extreme is time. That means if someone has been treated, the less likely they are to die. So the key factors I have summarized here from the matrix you've seen, you can see that age is having a correlation of 0.213, indicating a moderate positive correlation with death, suggesting that older age may be associated with a high risk of you dying. Ejection fraction, this one, it always indicates a better heart function. It has negative zero, so it's in the opposite sense. So there's a reduced risk of you dying if you have a better heart function. And then serum keratin, this one mainly is linked to a high risk. It has really a positive, small positive correlation. It likely looks at the poor kidney function. And then, so likely if you have this, you're likely to die. And this one suggests, since it's negative, the lower the levels of sodium, serum sodium, you're likely to have a high death. And then time, it is always, it's really negative. This is suggesting a strong correlation in the dataset, indicating that if you're under observation or treatment, there's a lower risk of you actually dying. So the other columns, sex and smoking, they have close to zero correlation. So they don't really affect highly lead to death. Diabetes, anemia, and high blood pressure, they are all still under one, indicating that while they could be conditions, may have individual health impacts. Their direct association with the event in this data set is limited. So apart from the correlation, so that now you've understood their target variables or features that you need, and you can go ahead and still further look at variables and their distributions. So you could look at age, how it's distributed. You could go into more details. So this is where now you look at the other statistical metrics. What is the minimum age? You can see it's 40. So for my data set, the highest observation I have is for a patient of 95. You can look at other also metrics like the percentile, quartile range, and all that. The mean distribution. So most of our data is at 60 years of age. We have most of our entries there. And the skewness of data, you can see it's close to, so this, like, it's not left or right skewed. So these descriptive statistics can really help you to really understand how these are really related. So it's like, for example, when you come here, you can see further how age is related with time under treatment. This is, we could go with, for example, let's use this with age, and yeah. So you can see most of these people have lower values within this age. So the different metrics you can really go after and look at. You can always switch, and instead of change, maybe you want to look at gender. How is it distributed? Of course, it's a Boolean. So there are so many things you can do. So we have been able to profile a data set, and it has informed us on what we can do. You can see that I already have in mind key key variables I would like to look to. And since it's kind of a labeled data set, I can use any supervised learning model, which we can look at later. So from there, if you're not still satisfied, and you, for example, myself, I'm not going to do data cleaning in this part, I can go ahead and do some little visualization via the Power BI tool. just by loading that data set, it's able to still give you the impression, something you can see here, the impression of how everyone is distributed. So we have entries of death at these and those that have died and those that are likely not to die, their outcomes. Then you're able to look at age factor. You can go further to say, I just want to look at, like we said, we saw time was quite a factor. So I can come here and say, I want to look at time. So you can see uh, those that had high treatment. For example, if I came here and want to look at mainly those that died, so you can see that those that are below 208, those that are with lower values, have a higher death rate compared to those with higher values. So there are many statistical findings you can do still via graphs, and I always prefer to use Power BI. Sometimes you can still do this via your other tools. You can write your visualizations using Matplotlib and all that. So we were mainly trying to profile our data and try to understand from our observation how best are we going to do this. And from that, we have seen that we have our variables in mind, and now we can go ahead to focus on these variables being key in the prediction, in the training of our models, and then the prediction of the outcome, whether someone is likely to die or not to die. So, my main essence here has been to show you that there is need to explore the data before you make any other assumption. You don't need to be strong in this niche. It even guides you if you're to go back to clients to ask them further questions, because they give you this data set you get to have in mind. Sometimes we IT experts don't know the domains much. For example, one gives you a data set of uh, air quality that has come from the Sentinel 5P satellite, and you are supposed to come up with an output. So always, first and foremost, is try to understand this data before you even go into cleaning and do that. And there's so good packages people have written out there.